Okay, this is our introduction to sequences, and we're starting with arithmetic sequences. You should already have looked at the websites that I put up onto Moodle, so I'm not going to go too slowly through this. So we're starting with the arithmetic sequence, and here's an example: 4, 7, 10, 13. So what we're going to do is we're going to look at this table. Just hang on a sec. So you can see I've just put in, we're going to do the first 5 terms. So in this sequence we've got 4 and then 7 and then 10 and 13. And I hope that you can see that the next one is going to be 16. But what I want to think about now is how did we get those terms? All right, the first term we didn't get, right? It just is, right? The first term is 4. That's how a sequence is defined. But how do we get from 4 to 7? Well, what is the pattern that we're following? I can see up here that to get from 4 to 7, I added 3. To get to 7, from 7 to 10, I added 3. And from 10 to 13, again, I've added 3. So 7 I got going 4. Oh, what's the matter? Come on, machine. Okay, I'm having technical difficulties here, so I don't know what's happening, if it's going to look the way it's looking, but let's just undo that. Right, what we want there is a nice little 4 plus 3. That's how we got our 7. We had a first term and we added 3. Now, to get to the 10, we just added 3 again. So we've got 4 plus 3 plus 3. And to get to 13, we added 3 again. So we end up with 4 plus 3 plus 3 plus 3. What I want you to notice is that here I've added 3 lots of 3. And that's my 4th term. So let's have a look at this. For my 5th term, I'm going to have the same, but I'm going to add an extra 3. So now I've got 4 lots of 3 added for my 5th term. If we go back, I can see that I had added 2 lots of 3 for my 3rd term. For my 2nd term, I had 1 lot of 3 added. And for my 1st term, I started with 4 and I hadn't added any 3s. So every time, whatever my term number is, 1 less than that is how many 3s I'm adding. So what we're basically doing is we're going plus 3, but how many times? 1 less than the term number. So let's go to the next slide. I can see that for my nth term, and the nth term is me writing a rule that's going to fit for any term, whether it's the 1st or the 2nd or the 3rd or the 4th or the 5th, I'm going to call it n. And I've got 4 plus 3 plus 3 plus 3 plus 3 plus ... Well, how many times? If it's the 1st term, I'm going to add 3 no times. The 2nd term, I'm adding 3 1 time. For the 3rd term, I'm adding 3 2 times. So for the nth term, I'm going to be adding 3 n minus 1 times. So I've got 3 plus 3 plus 3 n minus 1 times. So in this example, let's look at what that looks like. If I say now find T10, that means I'm going to have 4 plus 3 plus 3 plus 3. Hang on. How many times am I adding 3? 9 times, because it's going to be 1 less than this n down here. Okay, so I'm going to have 4 plus 9 times 3. Okay, 9 times 3, I know, is 27, plus 4 is 31. So I didn't have to write this out. I could have gone straight to here, and I'm just going to use a different colour to write near it what it will look like. I would have had 4 plus n is 10 minus 1 times 3. So that 10 minus 1 gives me the 9. And then 9 times 3 gives me the 27, and add 4 and I get 31. Okay, let's do some. So here's an example. This is the rule for an arithmetic sequence. Okay, I'm just turning my page. So this is my rule. So let's see what it looks like. T1 is going to be n is 1. So I'm going to get 5 plus 1 minus 1 times 2. Well, this 1 minus 1 is going to give me 0. So I'm actually going to have 5 plus 0 times 2. 0 times anything, again, gives me 0. So 5 plus 0, it's just 5. So I know that the first term in this sequence is 5. Let's look at T2. Again, I'm going to have 5 plus n minus 1. N is 2, so 2 minus 1 times 2, which is 5 plus, well, 2 minus 1 is 1, so just 5 plus 2, which is 7. Oh, I'm running out of battery. Don't die, don't die. T3 is going to be 3 minus 1 gives me 2, so 5 plus 2 times 2, which gives me, what are you doing? Stop it. Do not know what this thing is doing. It's going nuts. Okay, I don't know what I did then. Let's ignore that. Okay, where was I? 5 plus 2 times 2 is 9. Now, if I start looking at, I can see what I've got. 5, 7, 9. Here's my series, my sequence. 5, 7, 9. What's going to be next? It's going to be 11, I reckon. And after that, it's going to be 13. Because, look, I'm adding 2 each time. And I expected that I'd be adding 2 each time because, look, that's 2. Okay? So, what I've basically got here, I'm going to clear this screen, is a general rule that looks like this. Tn equals a plus n minus 1 d, where a is the first term in my sequence and d is the common difference. That is, how much does each term differ from the next. So in this example, 3, 5, 7, 9, 11. My A is going to be 3, just because that's the first term. My D, come on, work for me, it's not working. Oh, what are you doing? Try again. My D is going to be 2, because I'm adding 2 each time. So if I look back, I'm going to use a different colour now. If I look back up here, I can rewrite that as 3 plus n minus 1 times 2. There's my D, that's 2. There's my A, that's 3. So it's actually quite easy to find a rule if I'm given a list like that. Okay, so arithmetic sequence is when there is this common difference where I'm adding something each time, or I might be subtracting something each time. So let's have a look at my next slide. Here's question 1. Show that this sequence is arithmetic. Okay. If it's arithmetic, then I'm adding the same amount each time. So this is how I do this question. I'm going to go, what do I get when I do T2 minus T1? That's 11 minus 5. Oh, no, it's not. Sorry. That is 5 minus 11. T2 minus T1, which is negative 6. What do I get when I get T3 minus T2? Well, that is negative 1 minus 5, which again is negative 6. What about when I get T4 minus T3? That is negative 7, careful here, minus negative 1, which is the same as negative 7 plus 1, negative 6. So there is a common difference of negative 6, and therefore it is arithmetic. Okay, next question. Find rule for this arithmetic sequence. Oh, and I haven't written the sequence. Let's do it now. There's my sequence. Okay, so to find the rule, I need to find A and I need to find D. A is the first term. That's easy. 4. D is the common difference. 4 to 9 is plus 5. 9 to 14 is plus 5. So D is 5. So my rule then is simply 4 plus n minus 1 times 5. And that's it. That's all I need to do. Next question. Now, if you want to, pause the recording, have a go at this question without me. But I'm going to go ahead and do it. For the sequence with this rule, find the first 5 terms, the 10th term, and the 100th term. Now, because it's written out in the same way as my other ones, I can look at it straight away and I can read off the key information. There's my first term. There's my common difference. But be careful. This is a subtraction, right? So instead of adding something each time, I'm taking something away each time. So that means my common difference is actually going to be negative 2 and A is 3. So the first 5 terms is going to be 3. Take away 2 gives me 1. Take away 2 gives me minus 1. Take away 2 gives me minus 3. And take away 2 gives me minus 5. That's the first 5 terms. Okay, I might just write it as a sequence like that. All right, let's find the 10th term. Now I'm going to use my equation. T10, I'm going to put n equals 10 in. So I get 3 minus 10 minus 1 times 2. 10 minus 1 is 9, times 2 is 18. So it's 3 minus 18, which is minus 15. I'm going to run out of room. I think I've left room on the next slide. Yes, I have. And I've even given myself my equation there. So we're now looking for the 100th term. So the 100th term, 3 minus 100 minus 1. Because I'm just putting n, which is in there, I know that n is 100, so that's why that is 100. So 3 minus 100 minus 1 gives me, 100 minus 1 is 99 times 2. Now it's just arithmetic, which is 198. 3 minus 198, which is minus 195. Next question. An arithmetic sequence has the 4th term is 15, And the 8th term is 39. Okay, let's have a look at what that means. Here's my first term, second term, third term, 15, fourth term, fifth term, sixth term, seventh term, eighth term is 39. I don't know what any of these are. I can call that A, and I know that I went plus D to get from there to there, plus D for all of those, but I don't actually know any of my numbers. But all right, let's think about this a bit further. I'm just going to take a new colour. To get from 15 to here, I went plus D, plus D, plus D, and then plus D. So I've actually gone plus 4D to get from 15 to 39. Okay. So that means 4D equals 39 minus 15. 39 minus 15 is 24. So 4 times D is 24. That means D must be 6. Let's see if that works. 15 plus 6 gives me 21. Plus 6 gives me 27. Plus 6 gives me 33. Plus 6 gives me 39. It works, so I feel confident. I need the rule. I've got D, but I need my first term, so this is what I'm going to do. To go backwards, I'm going to go minus 6. It's going to give me 9. Minus 6 is going to give me 3. Minus 6 is going to give me minus 3. So A is minus 3. So my rule is going to look like this. Tn is minus 3 plus n minus 1 times 6. Okay. Next. Oh, not next question. Oh, I've got a blank page. Now we're looking at geometric sequences. All right, so here are some examples of geometric sequences, and what I want to show you is that this is what happens with geometric. It's different from arithmetic. Remember, in arithmetic I went up by an even number, plus 6 plus 6 plus 6, or minus 2 minus 2 minus 2. The geometric, I'm not adding and subtracting, I'm multiplying. To get from 3 to 6, I've doubled it. To get from 6 to 12, I've doubled it. 12 to 24, doubled it. 24 to 48, doubled it. Okay, I'm telling you that these are all geometric. So now let's work it out. Pause it if you need to. See if you can work out what I'm doing for the next two sequences. I'm timesing by 3. Timesing by 3. Timesing by 3. And timesing by 3. Now be careful here, because you're going to look at this and think I'm dividing. And I kind of am. Dividing by 2. But I'm going to call it timesing by half, which is the same thing. Timesing by half. 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 That's a geometric sequence. So I'm just using my first example. Just hang on a sec. All right. Here's my first to my fifth term, 3, 6, 12, 24, 48. But my question is, how did we get it? Once again, third term we didn't get. It just is 3. We just know. How did I get from 3 to 6? I timesed it by 2. This is the first example we did on the previous slide. Timesed it by 2. How did I get from here down to here? Timesed it by 2 again. 3 times 2 times 2. To get down to this one, I got that 3 times 2 times 2, and then I timesed it by 2 again. For my fifth term, I'm going to... Oh, it's playing up on me again. Come on, behave. Times it by 2 again. So 3 times 2 times 2 times 2. Now, let me just point out to you that I can write this as 3 times 2 squared. This is 3 times 2 cubed. This is 3 times 2 to the power of 4. And once again, we have this pattern. This 2, by the way, is to the power of 1, and that's for my second term. For my third term, I'm squaring it. For my fourth term, I'm cubing it. For my fifth term, I'm putting it to the power of 4. Can you write down what the general term is for this? Looks like this. Tn is going to be 3 times 2 to the power of n minus 1. Okay, that's a bit messy on this slide. Here is my general equation for a geometric sequence. Tn looks like this. A times r to the power of n minus 1. There it is. A times r to the power of n minus 1. What's A? A is still the first term. R is called the common ratio. Remember in arithmetic we had a common difference. That meant if I went the second term minus the first term, I got the same answer as if I went the 21st term minus the 20th term. Now it's a ratio. So I know, for example, if I've got, actually, undo that. I go back to my previous example. Here, T4 over T3 is, well, T4 is 24 over 12 gives me 2. That's my common ratio. T2 over T1 is also 2. It's a common ratio. And that's R. Okay. Let's do a couple of questions, see if we can get this finished before my battery runs out. Here's my sequence. 2, 6, 18. Question A is find the common ratio. Find the next term, find the rule, and find the 10th term. Press pause, have a go. Oh, actually, sorry, come on. It's slowing down, I think because I'm running out of battery. It's not responding. What are you doing, crazy machine? Okay, I'll stay on this page now. The common ratio, of course, 2 to 6 is multiplying by 3. 6 to 18 is multiplying by 3. If you don't know how to do that, I would have simply gone 6 over 2, that's 3. 18 over 6, that's 3. So I know my common ratio is 3. What's the next term? I need to multiply 18 by 3. I'm going to get 54. I'll just slot it in there. And now find the rule. Okay, well I know A is 2. And I know R is 3. So my rule is simply going to be 2 times 3 to the power of n minus 1. That's my rule. Okay, go back to the previous slide. Tn is A, where A is the first term, times R, where R is the common ratio, to the power of n minus 1. I should have put little times in there to make it really clear. Okay, so it's 2 times 3 to the power of n minus 1. And finally, find the 10th term. I'm just going to try and squeeze this onto this page. I'll use a different colour if I'm going to do that. Do it here. So T10 is going to be 2 times 3 to the power of, n is 10. 10 minus 1 is 9. Now I'm going to pause for a sec because I need a calculator for this. And I get 39,366. Wasn't that fun? So you need good calculator skills to do these. last question, I believe. I can skip that slide. For the geometric sequence, find the next term, find the rule, and find the sixth term. Well, in order to find the next term, I have to work out what I'm multiplying by. And actually, it looks like it must be a fraction because I'm going from 125 to 25. And this is how I do it. Negative 25 over 125 actually gives me negative 1/5. And let's check that with my next lot. 5 divided by negative 25 also gives me negative 1/5. So I know that my common ratio is negative 1/5. That means this will be a positive term, and I can see that anyway because it goes positive, negative, positive, negative. So this one must be positive because I'm multiplying by a negative number each time, and it's multiplying also by 1/5. Okay, find the next term. I've done that. Find the rule. I've got A. Let's take another colour. Here's A. And here is R. Alright, so just to remind you, my general rule is this: A times R to the power of n minus 1. So A is 125, and R, I'm going to put it in brackets, is negative 1/5 to the power of n minus 1. That's all I do. To find the sixth term, I change colour to avoid confusing you all. The sixth term, and I just put n is 6, so I go 125. Actually, there's an easier way to do this. 1, 2, 3, 4, 5. I'm just going to multiply one more time by negative 1/5. So get rid of that. T6 is going to be 1/5 times negative 1/5, which is negative 1 on 25. If you want to go through and use the equation, by all means. Now I think that's the end. Let me just check. Yes, we are finished. Oh no, question 3. There is another one. Okay, let's do that. This time I'm given the rule. Tn is 0.5 times 3 to the n minus 1. First of all, question A, what is the common ratio? That's this. The ratio is 3. Question B, write down the first 5 terms. I'm going to start with 0.5, and I know that because A is 0.5, and I know that because there is A written large as life for me. And then I'm just going to multiply 0.5 by 3, which gives me 1.5. Then I multiply that by 3, which gives me 4.5. Then I multiply that by 3, which gives me, 9, 13.5. How many do I need? 5. And I multiply that by 3, which, is going to test me. 39 plus 1.5 is 40.5 or 41. Hang on. 39, 40.5. Please check those. I'm not entirely sure. And just so I see it looks like a sequence, I might write it like that. Okay, we are going to go through this again a little bit in class, but we will have to move on to the next thing. So if you don't feel confident with this, please go back and have another listen. All right, see you next week.